So in this next section, we will either be given a table or a scenario, and we want to decide if it can be modeled by a linear or an exponential function. And then once we've decided that, we want to try to figure out what that function is. So let's look at example 1. It says a Seattle library had 18,000 books when they initially opened. Each additional year, they add 400 books to their collection. So the key part here is every year they add 400 books, and they're adding 400 books. And so that clues us into the fact that this will be modeled by a linear function. That word add 400 books. So if we wanted to create an equation out of this, we would say y equals, we know the slope is 400 because that's how much they're adding each year, and then x plus, and then the starting amount of books that they had was 18,000. And so let me just define for you our variables. So y would be the number of books, and then x is the number of years after opening. And so 400 again is the slope, which indicates that every year they add 400 books, and our y-intercept is 0, 18,000, which represents that the starting amount of books that they had was 18,000 books. Example 2 says Janelle buys a car for $13,000 in 2012. Each year after that, the value of the car decreases by 50%. So if I made a table of what that looked like, our input would be the years after 2012, and then our output would be the value of the car. And so when she initially bought it in 2012, the value was 13,000. And then the following year, if it decreases by 50%, then we would have the value of the car being 6,500. And then the following year, it would be 3,250. And the following year, it would be 1,625. And the following year, it would be $812.50, and so on. And so maybe pause the video for a second. In what way is the value decreasing? Is it decreasing linearly or is it decreasing exponentially? If it were decreasing exponentially, you would be subtracting the same amount each month, but that's not what's happening. To get from the one year to the next, how we're getting the output values is we are multiplying by a value of 1/2. Okay, so that means that with our exponential function, we would have y equals the starting value in year 0 of the car is 13,000. And then the b value that we're looking at is 1/2, because that is what we are multiplying each time. And then our exponent would be x. And so what are each of those things? Y here would be the value of the car. The 13,000 represents the starting value of the car. And then the 1/2, that's representing the rate at which the value is decreasing. And then x, our input, is the number of years after 2012. All right, so that one was an exponential function. The first one was a linear function. Okay, example 3 gives us a table. So what's the pattern here? notice that to go from 3 to 6 and from 6 to 12, we would be multiplying by 2, and same with the rest of it. And so if we're going to create our function, which is an exponential one, we would have y equals our starting value of 3 times 2, our multiplier, and then to the power of x. So that is our exponential function for this one. Let's move on to example 4. Again, we're given a table, and what is the pattern here? To go from 20 to 12 and from 12 to 4, what we're doing is we're subtracting 8. So that is our pattern. So our linear function for this one will be y equals -8, that's our slope, x, and then our b value will be 20 since our y-intercept is 0, 20. All right, so example 5 asks us to perform some calculations with exponential functions, and we want to round our decimals to the nearest hundredth. So most of these you should be able to throw into your calculator, so I'm just going to give you the answers and just make sure that you're able to plug them into your calculator and get the same answer. I do, however, want to show you how to do D because you might not know where the E value is on your calculator. If you don't know what E is a constant that is approximately 2.71, and it actually, that decimal goes on forever, so that's just an approximation. It's kind of like the number pi, and for a lot of purposes, we just round pi to 3.14. Well, same thing with E. It's actually a number that goes on forever, but we just round it to 2.71. So if we wanted to evaluate k of 11, that would equal 6 times e to the power of 0.2 times 11. And that's something we would want to throw into our calculator. So let me pull that up here. Okay, so then we would like to evaluate 6 times, and then the E button is kind of where the ln button is, but it's in blue, and the ln button is to the left of the 4. So we are going to need to press the second blue button and then press the ln, and that will give us e to some power. And then we want our power to be 0.2 times 11. And we want to make sure that 0.2 times 11 is all in the exponent, which it is. And then I'm going to press enter. So it gives us 54.15. So I'm going to go back to our notes. And so we will round that to 54.15. And then let me just give you the answers for the other ones. So those are the answers for the other ones. If you are not able to figure out how to get those, please make sure to ask your instructor.